Right. Can you believe it? This is now the last of the main functional groups that we are going to be looking at. That is the carboxylic acid. As I mentioned, we started looking at engineering students? Alkanes, alkenes, alkynes, benzene compounds, which are going to be calling aromatic compounds, alkyl halides, and the ones containing the benzene, which are going to call aromatic halides, alcohols, ethers, aldehydes, ketones. We looked at amines, and then now we're looking at the last functional group, which are going to call carboxylic acid. As the name implies, they contain what? They contain carbon atom. Now, an acid is a proton donor. A proton is just said to be. Any reason as to why H plus is said to be a proton? I think by now you know that that the hydrogen atom contains the nucleus containing the proton. I'm talking about the hydrogen atom itself. I'm not talking about its isomers like deuterium, which contains 1 neutron, and tritium, which contains two neutrons. So in this case, we say the normal hydrogen contains the proton, which is positive, and then the electron, which is negatively charged. So the hydrogen atom can lose an electron. So if it loses an electron in a reaction, then it means that the electron has been taken up by another atom to make it negative. So now the hydrogen will be left as positive charge. Now that positive charge, given that the atom does not have an electron, what is left there is just the nucleus with the positive charge. So that's why it's called a proton. Proton is just H plus. It means that you had a hydrogen atom and it has lost, it has lost an electron. That's why it's called a proton. So an acid is said to be a proton donor. It means that it can supply the positive charge to a species, and that species will attain a positive charge. Like ammonia, it can receive a proton to become an ammonium salt. Yeah. All right. So I'll just give an examples of typical acids that you are familiar with. They're called mineral acids. Like this is hydrochloric acid. It ionizes to form H plus, proton, plus the chloride minus. Sulfuric acid, it ionizes to form proton plus hydrogen sulfate. And the nitric acid, it ionizes to form H plus plus the NO3 minus. Yeah, that's the nitric acid. Yeah. Okay. So a carboxylic acid is a proton donor containing the carbon atom. So are you seeing something familiar to what you've discussed so far? There are two functional groups which on this structure which you've encountered before. The one which I'm showing in red, okay. There is the carbonyl group, that is the carbonyl group, carbonyl, and then the one which I'm going to highlight in blue is the alcohol group, the OH group. So this group, when they are joined together, they form the carboxylic group. So it can lose a proton here to form this one, which you're going to call carboxylate, the carboxylate ion, and then the H plus will be released into the solution. Can you see that? So in this case, this is where you're going to be attaching the groups to be able to make it complete. So the simplest carboxylic acid contains the hydrogen atom attached to the carbonyl group. So this tells you, if I can show you with the structure, the simplest carboxylic acid. But now I think you are now familiar with with these letters and the atoms they represent. Black, carbon; red one, oxygen; oxygen; white one, hydrogen. So in this carbonyl group, carbon oxygen double bond, the bond angles are 120 degrees. Yeah. So I've got a what? I've got a hydrogen attached to the carbonyl group, and then here this is my OH. Yeah, OH group. So this is what I have here. Perhaps if I may show it like this, perhaps if I may show it like this one, this is what I have here. Perhaps you'd see it as making sense. Yeah, carbonyl, oxygen, hydrogen, and then there's the hydrogen attached to the carbon. Can you see that? This is my structure. So this is the simplest carboxylic acid. And the way they are named as far as the IUPAC is concerned, ALK, alkyl group, is an indication on the number of carbon atoms. This simplest one contains one carbon atom. So that is meth for one carbon atom. And you just need to add the ones which are shown in red, anoic acid, to make it the name. So for one carbon atom it will be called methanoic acid. For two carbon atoms, ethanoic acid. Now in this case, if it has, like in this one has got 4 carbon atoms, it will be 1, 2, 3, 4. Butanoic acid, yeah? Alright? Butanoic acid. Now, a carboxylic acid, where there is the carboxylic acid group, which I'm going to highlight here, that's where you're going to number as carbon number 1. So this butanoic acid, I've just redrawn it the other way around, in which this OH is on this other side. So that carbon is still carbon number 1, 2, 3, 4. In this case, you are naming from right to left. 1, 2, 3, 4. In this case, you are numbering from left to right. 1, 2, 3, 4. So this is still butanoic acid. So this one can also be drawn like this one. This is CH3, CH2. Oh, okay. So this structure of the butanoic acid, it can be simplified to this, my CH3. These are 2 CH2s. And then the carboxylic acid, it can also be summarized as COOH. So you can see in some books, they are showing the carboxylic acid as COOH. Okay? COOH. So this is similar to carboxylic acid. Are you seeing that? This is carboxylic acid. So later we are going to see how we are going to have different functional groups on the same structure, and then we'll see how we can be able to name it. But that's the much I'll talk about, how the naming of the carboxylic acids. So I really hope you've really enjoyed. This one is quite a short lecture of about 8 minutes, but gives the important points about the naming of carboxylic acid. Yeah. And then later, once we are through with how we can name all the compounds containing the different functional groups, we'll be able to now look at the properties of the functional groups that we've dealt with, yeah, from alkanes up to carboxylic acid. So I really hope you've really enjoyed this lecture on the naming of the carboxylic acid. So thank you very much, and I hope you've really enjoyed what you've talked of so far, and I hope everything is clear on the board. All right? So thank you very much.